Hello and welcome to Module 5 in the short course on risk assessment for food safety. Today we're going to talk about exposure assessments, and I have two modules on exposure assessment. This one is about the amount of the hazard in the food and how we estimate that. This is step 2. Exposure assessment is step 2 of a risk assessment. So we'll talk about amount of hazard in food in this module, and then in the next module we'll talk about estimating how much food people are consuming. So I broke those up into two parts. So the learning objectives for this module are first to understand how information on the amount of a hazard in food is used in the exposure assessment process and ultimately in a risk assessment, and then also to understand the type of data that is needed to assess the amount of hazard in a food. So exposure assessment is the step where, so remember, in hazard identification was the first step. That's where we decide which hazards we're going to focus on, which pathogens, which chemicals, if you're doing chemical risk assessment, which group of pathogens or chemicals. So which particular hazard you're going to focus on, that's hazard identification. And then now in exposure assessment, we're talking about estimating how much of that hazard is part of what the person is being exposed to. So we, in this step, are assessing the amount in the food, the amount of hazard in the food. So we're going to use this to estimate an exposure rate, which will be something like an amount per day. So it might be milligrams per day, it might be some kind of units per day. So we need information to be able to estimate this exposure rate to food. So imagine you eat 3 chicken sandwiches a day, and there's 2 grams of something that is a hazard in chicken. Then you would say, there's 2 grams of hazard in each chicken, and I'm eating 3 a day, so that I'm being exposed to 6 per day. So that's the basic math behind what we're doing in the exposure assessment. So the first thing we're going to talk about is how do you get this data on how much of the contaminant is in the food. So later, we'll talk about, in the hazard characterization step, which is step 3, we'll talk about how much of the food can make someone sick. So this is just the part about exposure, which is just how much the person is being exposed to. We're not talking yet about whether or not this amount makes people sick. So the methodology is that you calculate this dose of the hazard in food per time. So it's not a constant number, of course. One day you might eat 3 chicken sandwiches, one day you might eat 1 chicken sandwich, one day you might eat 0 chicken sandwiches. So there's always going to be some variability in these daily estimates. And there's always going to be some uncertainty in the measurement because, of course, you're not actually collecting data. You're asking people to remember, or you're collecting data on a snapshot in time. So there's going to be variability and uncertainty in these estimates. So chemical and microbial hazards are measured in different ways in terms of the concentration numbers. They have different, as we mentioned earlier, they have different kinds of impact on human health, and there's also just different kinds of science is used to measure these, and different kinds of metrics are used to represent the amount of contamination in a food. So I just wanted to give you a real simple conceptual model of how hazards get into food. We're talking about measuring it at the point of consumption in terms of what the person's eating, but conceptually it's good to kind of have an understanding of why there's these hazards in foods. And so on the chemical side, as we mentioned in a couple modules ago, these are often through environmental exposures. So this is an example of a PFAS, which is a chemical that's been of concern in the United States lately. This is a map that was created by the Michigan, one of the state's environmental resource group. And so it talks about how there can be things coming into the air or water from industry, things coming into the air or water from landfills that are getting into the water system and then being distributed on a crop. So this is a conceptual model to kind of help give you an understanding of where these hazards are coming from. This is the chemical side. And then on the microbial side, it's a little bit different. A lot of the microbial pathogens that make people sick are naturally occurring in animals and wildlife. So similar kind of ideas that somehow those contaminants get into the ground where things are growing, get into the water, can lead to contamination of vegetables, and also to contamination of meats. So I just wanted to give you these two kind of conceptual models to give you an understanding of why these contaminants end up in foods. These are obviously very oversimplified and kind of get to some of the things that we'll talk about in our risk prioritization workshop, where we're looking at what are the possible interventions you could do, where are the places that you could control this contamination or manage this contamination in a way to reduce its likelihood of getting to the final food product. So that's part of the risk prioritization step that we'll talk about in our last short course on risk ranking. So where does this data come from in terms of contamination levels of food? Well, it's based on sampling and testing of the food. So at some point you need to start with information about the food that's being consumed and taking samples of it back to the laboratory. And so since not all food can be sampled all the time, a sampling strategy should be developed. So statistics has given us tools to say, well, if you want to, represent the entire amount of chicken that's being consumed, this is how many samples you should take, this is how often you should sample, this is how you should process the sample. So there's a lot of science behind that work to decide on a sampling strategy. And there's always going to be uncertainty, because you're always just, when you're taking a sample, you just have a snapshot in time and you only have a small representation of the whole system. So choosing where to take those samples and understanding how to statistically analyze that data is an important part of developing a strong sampling program. So we do often use in risk assessment probability distribution. So when you have uncertainty and variability, we're not going to go into that a lot here, but some of the more advanced materials talk about using probability distributions to represent uncertainty and variability in risk assessment models. And that's an important component, because we know that if we just use a point estimate, if we just take a sample of some chicken and average together and say this is the concentration in chicken, we know that that's not really true. We know that there's some uncertainty about whether that data really represents the true number, and you want to be able to capture that when you're doing your risk assessment. So collecting samples of food for laboratory testing, the laboratories, there need to be chemical laboratories and microbial laboratories. They have different kinds of skills and expertise, different kinds of scientists, different kinds of tools and labs and methods. And as I mentioned, the statistical expertise is also needed, not only to decide where to collect the samples, but also to decide how to analyze the data after it's been reported out and how to use it in a risk assessment model. So, ideally there would be some kind of ongoing surveillance over time in a food safety system to be able to collect that data on contamination and kind of be able to understand where the concentration is really happening. I do have an additional video on Carmen that I think is really helpful. It was created by Wageningen University in the Netherlands, and it's about consumer contamination routes, and so I put that up there as a resource. It just kind of, again, talks through some of these places that contamination comes from. So I hope that this module introduced you to these concepts and met these learning objectives, which are to understand how the amount of food in a hazard in a food is used in exposure assessment, and then the type of data that you would need to be able to assess the amount of hazard in a food. The next module is going to talk about exposure assessment again, but focusing on how do we estimate how much food people are consuming.